so much for coming out tonight. I really appreciate it, especially given the fact that it's a rainy night here in Baltimore, and there's also an important NBA playoff game. And the fact that you've chosen to be here with me, I'm gratified, and I only ask in return that if you know the score, you don't tell me, because I'm going to try to watch. Oh, it's not on? Do I need to push a button?
Yes.
Excuse me a moment. You're missing all my witticisms. Now watch while I do this gamely effort to... What do I do?
Oh, I haven't used this one.
What about this? It says push.
Yeah, it's green.
Did that work?
All right. How many astrophysicists does it take?
Yeah. Rocket scientists in the house? Yeah. Anyways, yeah, so if you know the score of the Bulls-Wizards game, don't tell me so I can watch it later. And also a big hello to any of you watching on the internet tonight. Hi, Mom. Hi, Dad. And at least I know those of you watching on the web are watching the basketball game at the same time. That's what I'd be doing. Or you're like, oh, a timeout. Quick, let's watch some astrobiology. All right. Anyways, so Terra Sapiens, the human chapter in the history of Earth. What am I, a mere astrobiologist, doing talking about this? Well, it all began when I saw an advertisement for this kind of unusual job that was mentioned in the introduction. A couple years ago, I saw that there was a new position being established for a chair of astrobiology in the Library of Congress, jointly supported by NASA and the library. And they were specifically, and that kind of caught my attention. I said, wait, what are they talking about, a chair of astrobiology at the library? I've never heard of such a thing. And then I read the fine print, and it said they were specifically looking for somebody to do sustained research at the intersection between the science of astrobiology and its humanistic and societal aspects. And I thought, maybe that's an opportunity to write that book I've been thinking about and had back-burnered for the last several years about human civilization as a sort of almost astrophysical or cosmic phenomenon. And so I already had a proposal in the works, which I reformatted in the proper form for this proposal and added some other things and sent it in, and I was very gratified to be selected as the inaugural astrobiology chair. And the title of my proposal that I submitted was this: Astrobiology and the Anthropocene Era, Exploring the Potential Roles of Life and Intelligence on Earth and Beyond. Well, what are we talking about here? So astrobiology, as some of you I'm sure know, is the scientific study of life in the universe. So we study very carefully the record and history of life on Earth and the extremes of life on Earth, trying to understand the limits and universals of life. And we also study the environments in the rest of the universe to try to extrapolate and understand where the universe may be life-friendly. And so that's the field of astrobiology. The Anthropocene is a new term that is becoming to be widely used, which I'll talk about a lot tonight, but it's the idea that we, in fact, have now entered a new era or phase of geologic history of the Earth, defined by the actions of human beings as a major geological force. It's not a value judgment. It's not necessarily saying this is good, this is bad. It's just recognizing that if you add up what humans are doing now, it is comparable to the other great forces of nature. So my idea was to look at this Anthropocene era from an astrobiology point of view, and that's what I've been doing for the last year, and I'll summarize a little bit of that for you this evening. So, the Anthropocene. As I said, it's the word that's now being used, and it's in fact been proposed as an official term in the geologic timescale. That proposal is now up for review and being considered, but it's also come to be widely used, whether or not it gets officially sanctified as a geological term. And the idea is that we've become a dominant force of planetary change. And there are many interesting ways of looking at this. And one way is to look at the different ways we measure time. We think of geological time over here on the left. We think of the history of life, biological time. And we think, of course, of history, the history of civilization. And in a sense, with the Anthropocene, we're realizing that these have all become braided together, perhaps irreversibly, that in a certain sense, there may be no more history without geology, and vice versa. So people have been looking at this, and there's a lot of data on this, and I'm going to go through this part very quickly because it's not my goal here to convince you that humans, in fact, have become a dominant force. I think you're probably aware of a lot of this, but just to summarize, if you look at so many, these are all different indicators of human presence on Earth, and certainly if you look at your population and things like damming of rivers, what we've been doing to the water cycle, the hydrological cycle of Earth, here's a weird fact, that there is now more water in reservoirs behind dams on Earth than in all the natural flowing streams and rivers on Earth, by a factor of 5 or 6 more water behind dams. So that's not a minor effect we've had on the hydrological cycle. Similarly, you can look at so many of these other indicators, and here's sort of a funny, facetious one, McDonald's restaurants, but it actually is an indicator of fertilizer use. We're really changing the nitrogen cycle of the planet with this. And the interesting thing is that you can see a common form to all of these. You know, they're not exactly the same, but you can see a similarity. And in particular, there's this big jump post-war around 1950 in a lot of them. And that's something that scholars of the Anthropocene call the Great Acceleration. And there's different ideas as to why that happened, but a lot of it had to do with the sort of suppression of a lot of activity during the wars and then the explosion after that. So these are all indicators of human presence on the Earth. And then this next slide, I'll show you one more slide of data. These are all indicators of the sort of human effects on Earth systems. So the obvious ones, CO2, of course, going up, and other atmospheric gases, and ozone, you know about, different climate indicators, the number of great floods, biodiversity changes, and again, you see a lot of this sort of, they're not identical because there's this complex system, but you see this common form with the great acceleration in a lot of these. So there's really no doubt that we are having this massive effect on our planet. So what is the context through which we should think about this? Well, as an astrobiologist, I'm drawn to thinking about things in terms of the really big picture, in terms of cosmic evolution. And by the way, as was mentioned in the introduction, I'm here this week for this extraordinary meeting. It's been so interesting. It's a workshop here, a symposium here at the Space Telescope Science Institute called Habitable Worlds Across Time and Space. And it's so interesting because people are talking about all these different things that are represented here in this cartoon, about galaxy formation, and star formation, and planet formation, and where you might get life in the universe, and even the evolution of complex life. So this is a one-page cartoon history of the entire universe, but it's meant to point out, when we think of cosmic evolution, we think of sort of the major transitions that the universe has gone through, especially in terms of the way matter is organized. And so obviously, originally you had the Big Bang and you formed galaxies, and then in these magnifying glasses is sort of what's happening on the micro scale. So you start getting, the galaxies and stars give birth to the elements, and then you get simple organic molecules in interstellar clouds and the environments around young stars. And then on the surfaces of at least some planets, you get more complex molecules. And at least on one planet, we had an origin of life, and then organic molecules frolicking in the primordial glop of a young Earth. And voila, here we have the evolution of complex life and what we so perhaps vainly call civilization. And it ends here with question marks about what's next, because why should we assume that this is the apotheosis of cosmic evolution, what we've got going on right here. But the other thing I'll point out is that part of what we're driven to do in astrobiology is try to understand how universal these processes are. So everything on the left side of this cartoon is known to be universal. There are galaxies and stars formed everywhere in the universe. And we're driven to wonder if these things on the right side are also similarly phenomena that are widespread and not just unique to this location. Now, the great news, of course, in the last decade or two is that now we know that planet formation is, in fact, common, I would say universal. We didn't know this even really a decade ago to the way that we know it now with the wonderful Kepler mission and the other discoveries you've been hearing about. But now you know when you look up at night at the stars that most of them, almost all of them, have planets. And a sizable percentage of them probably have planets that in some significant ways resemble our planet. So that is new and profound. We're moving some things into this column of that we wonder about how universal they are to, in fact, knowing that they're universal. But we're still on the trail of these last two developments, life and complex life. That's what we're driven to understand. Now, the story here locally began about 4.6 billion years ago with a process we call accretion, where this disk of dust and gas around the young sun went through this process of congealing and conglomeration and falling together of larger and larger objects and more violent collisions. So there was this crashing and bashing and smashing and a sort of demolition derby, and that, as the objects got larger, their gravitational pull got larger and their forces between them got larger, so the final stage was quite violent collisions, including the late collision that where a very large object hit the Earth and splashed material into orbit, which made our moon. And that was sort of the end of accretion, really, other than just a little mopping up. So it was really this gravitational accretion that formed the planets. Now, I'm going to skip some steps and rush ahead about 4.5 billion years, but something remarkable has happened on one of those planets. If you had been watching Earth, say you were a patient alien watching Earth for all of these billions of years, you would have noticed a lot of activity in the interim. Say you were watching the night side of Earth. It would have been pretty dark throughout most of that period. Yeah, you would have seen the occasional flash of lightning, the occasional splash of aurora, the northern and southern lights. And then more recently, in the last few 100 million years, once the continents got forested, you would see the occasional forest fire. Maybe once in a while you'd see a glowing volcano. But in general, the night side would have been very dark. And then very recently, to your alien eyes, something really remarkable would have happened. And these networks of lights, these glowing areas, would have sprung up first on some of the coastal areas and then the little filaments of roads between those inhabited coastal areas. And you would have said, wow, something new and remarkable is happening on this planet. And undeniably different. And not only that, but if you were a very observant alien, just in the last 50, 60 years, you would have noticed a curious anti-accretion, where a few little bits of the planet started flying back off out into space in seeming defiance of the laws of gravity and going back out to the other planets and sending radio signals back. And so it's a curious anti-accretion in two senses of the word. It's curious in that it would be very strange if you didn't understand what was going on, but it's also the hallmark of curiosity. A species on this one planet has started to send emissaries to the rest of the solar system asking questions, seeking information about origins and context. So there's a lot one can say about what we've learned through comparative planetology, and that's actually my day job, to the extent that it could be considered a day job. So to summarize sort of a life's work in one slide, one thing we've learned through this study, in particular through studying the trio of Venus, Earth, and Mars, which is very compelling because these are the two planets that seem to start out Earth-like and then go off in their own directions. What we've learned is that surprisingly, these planets seem to have very similar origins and early environments. You've heard all about the early water on Mars. We're still learning more about that, but there's a lot of evidence that Mars was a warmer, wetter place when it was young. And Venus, too, we think had had oceans and a sort of warm, friendly surface environment when it was young. We've got to do a lot more exploring to really get that story straight. But that's what we think. They had similar origins. And so it may be that the conditions for the origin of life are common, that rocky planets start out that way and start out with similar conditions to those that on Earth seem to facilitate the origin of life. And it may be that what's rare is the persistence of a habitable planetary environment over cosmological timescales, over billions of years. So it seems like Earth, compared to its neighbors, went down a different path. There was an early divergence, an origin of life, which has had profound effects on the further evolution of the planet. In fact, my colleague, Colin Goldblatt, at a recent meeting, put it this way. He said the defining characteristic of Earth is planetary scale life. And Earth teaches us that habitability and inhabitants are inseparable. In other words, the more we study the Earth, the more we realize that that life has really got Earth in its clutches in a deep way. Obviously, it's changed the atmosphere. It's changed the look of Earth from space. It's changed the hydrological cycle. But even more and more now we're realizing it's changed the rocks and the minerals. We heard a great talk about that today, that Earth has 3 times the mineral diversity because of life. There's the range and number of minerals that the chemistry of life does to it, that it would have if it was a lifeless planet. It's even changed the interior properties of the planet. So life, it was this early branching point, and then subsequently, for nearly 4 billion years, Earth has been evolving under the influence of global forces that have seemingly not been at work on our neighboring planets. So there was a branching point. And what I'm interested in is the possibility that what we're going through now, the Anthropocene, looked at in terms of cosmic evolution and the kinds of things that can happen to planets, maybe in a certain sense another branching point. More recently, as illustrated here by this illuminated night side Earth, Earth has come under the influence of a new type of geological force, the global activities of humanity defining the Anthropocene. So again, I want to sort of try to present a context to think about that. Now, we are not the first species, the first kind of life to come along and profoundly change the Earth. In fact, the most extreme transition ever in Earth history happened a little over 2 billion years ago, and it was the Great Oxygenation Event. Now, we think of oxygen as this wonderful thing, and we're glad that the Great Oxygenation Event happened because we like oxygen. I love oxygen. It's a good thing. But at the time, it was a disaster. It was a profound change, and it led to a mass extinction because oxygen is poisonous to organic life. Life now has evolved to make use of that violent reaction that oxygen goes through with organic chemistry. That's how we live. We power ourselves on that combustion reaction. But when the oxygen first appeared and life didn't know how to handle it, it was disaster. A lot of species went extinct. So oxygen is poisonous, and not only that, it may have caused a great, huge global climate disaster. There's something that we call the Paleoproterozoic snowball Earth. It's one of the few times in history when Earth has become completely iced over, and may have become almost irreversibly iced over. There's a state where it can become stably glaciated because when a planet gets iced over, it reflects more sunlight and sort of keeps itself cool. Fortunately, the volcanoes came to the rescue and pumped up CO2 and got us out of that trap. But nonetheless, it's a scary thought that a planet, if a planet's a little bit farther out from the sun, maybe it could get trapped in that state. So what happened was, probably at that time, Earth was being kept warm by a methane greenhouse, a CH4 greenhouse. And then the oxygen came along, and oxygen destroys methane, and it collapsed the climate and led to this global freezing. So it could have been a close call to irreversible planetary destruction. And my slightly facetious way of describing it here is that by innocently exploiting a new energy resource, because that's all that the cyanobacteria who did this were doing, they said, oh great, solar energy, we love it, let's multiply and do more and more of it. Free energy, that's all they were doing, was exploiting an energy resource. What's happening? How weird. I started hearing myself. Put the kibosh on that right away. It's going to mess me up. All right. Those irresponsible bacteria caused a global environmental catastrophe. Now, I'm joking because I don't really think that bacteria are capable of being irresponsible. But looking at that question, what is the difference between what we're doing, between us and the cyanobacteria, is one interesting way of thinking about the transformation that's going on now on Earth. So, as I said, we're not the first species to cause global change. So what have we got that the cyanobacteria didn't? Well, now you get into what I'm sort of grouping together as human qualities here. And these are all sort of loaded concepts, and we could argue them, each one. It's an interesting question, really, what does distinguish humans from the rest of life? But these kinds of things are what are usually discussed. Language, tool use, art, technology, intelligence, consciousness, foresight, awareness, responsibility. Any one of these you could argue, but I think collectively you get the idea. They form this set of qualities that makes us human and differentiates us from, for example, the cyanobacteria. Now, somebody joked to me, and I think in a way it's true, that these are actually all the things that we don't have quite enough of to get ourselves out of this predicament. Maybe true. But, you know, it's interesting to look at this as a group of qualities that we have, and you can ask in evolutionary terms, are these qualities adaptive? That is, do they facilitate survival, or are they in some way an evolutionary dead end? Could they be a potential gateway to great longevity? One can see how they might be. These are ways of solving problems, and obviously, you can imagine problems that can be solved by creatures with these that without these qualities would threaten your existence. If an asteroid is heading your way, the cyanobacteria wouldn't be able to do anything about that. In theory, we could. So one can imagine these as qualities that might threaten our survival or might ensure it. And if civilization is now a planetary process, what are its prospects here and elsewhere in the universe? Are there things about this list that can be extrapolated to evolution of complex life on other planets? So, in order to get a little more of a handle on this, and again, working on this question of how to contextualize what is happening, I'm going to present to you sort of a taxonomy of catastrophe here. I've looked at the different kinds of planetary changes that happen, not just on Earth, but on planets in general, and I've grouped them into 4 categories, classified with respect to the influence of life. And I call them natural disasters, biological catastrophes, inadvertent catastrophes, and intentional changes. And let me say a little bit more what I actually mean by these 4 kinds of planetary change. So planetary changes of the first kind, natural disasters, I don't mean exactly what we normally mean by that phrase. What I mean specifically is drastic changes that happen to a planet where life had nothing to do with it. Life is not implicated. Life is an innocent bystander. So the obvious example is an asteroid impact or a comet impact. And this has happened several times over the history of the Earth, most dramatically 65 million years ago when the dinosaurs and everybody else around at that time, or most everybody around at that time, went extinct because of the drastic changes caused by an impact. But there are other examples that I would put in this category as well, what we call large igneous provinces or major volcanic episodes where the Earth goes through some sort of burp in its interior and there's a massive outpouring of lava. And some of these are so dramatic that they cause huge climate excursions, and we know they can lead to mass extinctions. Some of the famous ones, the Deccan Traps in India, close to the time when the dinosaurs got wiped out, over 60 million years ago. The largest one on Earth was the Ontong Java Plateau here in the South Pacific. And the Siberian traps up here in Siberia have recently been implicated in the greatest mass extinction of all, what we call the Great Dying, or the Permo-Triassic extinction 250 million years ago, happened to be just at that moment when there was a massive outpouring of volcanic lava and the gases that change the climate and change the chemical environment that life needs 250 million years ago. Now it turns out that the plot thickens and that particular catastrophe might have been a combination of Category 1 and Category 2 because there was a biological component to that where it seems as though bacteria that made a lot of methane might have contributed to that extinction. So that brings us to planetary changes of the second kind, biological. And I symbolize that here with the green leaf because the best example of that is the one I've already been talking about, the evolution of photosynthesis, which was very much the result of biological evolution and led to a huge catastrophe, a huge change in the chemical and climate state of the planet, and mass extinction and all that follows. Now, the third kind of change I want to talk about is basically what's happening now. Inadvertent change. And I'm symbolizing it here by traffic. And these are all the kinds of unplanned but massive changes that humanity is inducing on Earth. And the fact that we are having these huge effects on the planet, but it's not intentional. Nobody got together and said, hey, let's change the CO2. It's just happening as a result of our success at solving certain local problems with technology. We have these global unintended consequences. And this leads to what I call the Anthropocene dilemma, where if you have a species that has global influence without global control, then sooner or later that will lead to some kind of a catastrophe. And we're experiencing that now. Some other examples of this, well, obviously atmospheric CO2, and this is what we call the Keeling curve, CO2 changing over time, and this plot's a few years old, it's a decade old, and now you'd have to extend this up. We've just crossed over 400 parts per million CO2, and the consequent effects of that, of course, the very worrisome disappearance of sea ice in the summer and fall. And another example, though, that's interesting in this context is what you've heard about the ozone hole, where we realized that what we thought were harmless chemicals that we were using down here in the troposphere where we live, when they filtered up to the stratosphere, were having these potentially disastrous effects. By the way, the fact that chlorine chemicals destroy ozone was discovered in no small part because we were exploring the planet Venus. And people were trying to understand what was going on with the oxygen in the upper atmosphere of Venus and said, oh, well, maybe if there's some chlorine, let's model that. And they went, whoa, chlorine eats oxygen chemicals. And then somebody else said, wait a minute, we're putting chlorine in Earth's stratosphere. What's that? Oh, and sort of sounded the alarm. And so this is an example of how planetary exploration and the larger intellectual exercise of comparative planetology can help us out here and make us smarter about our own planet. But it's also an example of the next kind of change, the fourth kind of change that I want to talk about, of planetary change, intentional. Because the nice thing about the ozone hole in this context is that it's actually being fixed. The problem was recognized, international discussions ensued, international agreements were formulated, and it's being fixed. It's not perfect. There's still some illegal bootleg using of Freon, but it's enough so that we're on track, and if we continue on the path we're on, the ozone is going to be okay. So it is an example, a proof of concept, if you will, that this fourth kind of change, which in this context I'm saying is a different category of global change, is possible, intentional change. And now I'm going to tell you some other examples that I think fit in that category. So what do I mean by intentional global change? Well, I'm talking about change by truly intelligent life. And in fact, you can say, what do I mean by that? Well, I'm actually suggesting here that this is an interesting way of defining intelligent life. That maybe a planet doesn't really have intelligent life in a meaningful way until you get life that can enact this kind of global change, or at least it's a certain interesting definition of intelligence. Because what good is intelligence? Certainly what good is technological intelligence if it's self-destructive. That's not really, doesn't seem all that smart or intelligent to me. So one might say that this is a way you could think about defining intelligence, or certainly an interesting and worthwhile development on a planet to reach the stage where you have this kind of intentional global change, where intelligent life, acting with forethought and an awareness of its global role and the global consequences of its actions, takes responsibility. And so here's some examples. I mentioned ozone replenishment, which is already underway. Yay. Now, another example would be intentional halting or reversal of industrial global warming. Now, that's currently under discussion, and you could chuckle when I say that, but actually I see that as hugely important. It's a big change. This wasn't true. We weren't having a global discussion about this a decade or certainly 2 decades ago. Now, you might worry that it's too little, too late. I worry about that, but I think the fact that there is now a growing global awareness and discussion of this is actually hugely significant and quite positive. Now, other possible examples of this, planetary defense, and now I'm talking about defense against asteroids, which sooner or later would do in the biosphere in a major way like they did in the dinosaurs and their fellow species at that time. But we know now how to find the dangerous asteroids, and we think we know how to stop them, to build a planetary defense system. And it's a work in progress because we're already doing the necessary observations, and people have plans and ideas about how to do this. And in fact, if we found a dangerous object and we had a decade or so, which we probably would, we could do something about it. So we may have already passed a threshold where that's not the threat that it was. Now people talk about geoengineering. That's very controversial, rightfully. It's not the kind of thing you want to do callously or ignorantly, but my view of geoengineering is it would be foolish to attempt it before we know what we're doing, but that in the long run it will probably be a good idea and be necessary. And I'll talk a little bit more about what I mean by the long run. Another example that I would claim goes in this category is the terraforming of Mars. The idea that we could take another planet and make it more Earth-like and a friendly place for Earth life if we wanted to. Now, whether or not we do want to is a different question. There's a whole ethical dimension of this. And I'm comforted by the fact that we don't currently really know how to do this, because I don't think it would be a good idea to rush out and decide to do this. I was on a panel once with Arthur C. Clarke. He was on the panel by satellite, and mostly the satellite link didn't work at all, and we couldn't hear him, which is sort of ironic since Arthur was invented communication satellites. But the question of the panel was, should we terraform Mars? And Arthur's voice actually, in a ghostly way, came in loud and clear for him to say one phrase, and then it disappeared again. And the one phrase he said was, "Well, I think we should ask the Martians first." True story. But he's right. I mean, we don't want to even think about really doing this until we know if there are Martians or if there have been Martians. It would be foolish. But what I think is very positive about this is that it's caused scientists to really think. I mean, people have gotten together and had workshops about how you would do this, and it's caused us to think about how we would intentionally change the climate of a planet. And so as an exercise in trying to understand how climate works and what are the limits of natural climate change and what are the possible ways that, as opposed to inadvertently changing a planetary climate like we're doing now, how could you consciously change the climate of a planet? So I think it's been a very worthwhile exercise to think about that. In the longer run, sorry about the nerdy phrase here, Milankovitch cycle, what I mean is ice ages. In the Earth, left to its own devices, in the long run, is not a friendly place for a global civilization. Earth goes through these dramatic climate changes all by itself, just on longer time scales than we're used to thinking about. We do not want to live through another ice age. We could not sustain the population that we have now with agriculture and so forth. And so if we're around, if we solve our more immediate problems and we're around for thousands of years, we probably will want to do something about that. And it wouldn't be that hard. if we can have the kind of effect inadvertently we're having on the planet now, it's not really a larger effect that we would need to have intentionally. In fact, it's probably a smaller effect applied in the right way to intentionally avoid an ice age. So at some point, if we get through our current moment, we'll be able to do that. Now, thinking on much longer time scales, and now I'm really thinking far future, but again, I think it belongs in this overall category, eventually the sun is going to age, and the Earth, left to its own devices, will go through a runaway greenhouse like Venus did in the past and become uninhabitable, unless we do something about it. Now, that's billions of years in the future, but I would imagine, or at least a billion years, I would imagine if somehow we or our descendants or our creations or somebody with something going on up here or wherever it's located at that point is around, that they would have had a lot of time to work this problem. And so this is a sequence of ideas on different time scales about how intentional global change might manifest. Now, I've given you these 4 kinds of planetary change. Let's think about where they might exist elsewhere in the universe. Natural disasters, I think, will occur on all planets. Certainly on any planet interesting enough to have life, it will be changeable. There will be impacts. There will be volcanoes. As the bumper sticker goes, stuff happens, right? And that will be true. So this will be unavoidable anywhere. Biologically induced catastrophes, I think, will occur on all planets with life, even though we can argue about what life is and what its properties might be universally. And believe me, that's what we astrobiologists do. It's almost all we do is argue about that. But I think it's safe to say that life is something that multiplies and alters its environment. And if you just have those 2 qualities, then I think it's true that sooner or later life on a planet will cause environmental catastrophes and then have to deal with the aftermath. Well, what about these last 2 categories, inadvertent catastrophe and intentional change? When we start wondering where else in the universe those might happen, then we're in the realm of SETI, the search for extraterrestrial intelligence. And you can start asking this question, are we alone in the universe? Is there something about this story that makes it a common story? And one of the values of thinking in this way is it makes us think of the long term. When we think about other civilizations and whether or not they might be out there and whether or not we can find them, the conversation always leads to the question of how long civilizations last. If they don't last very long, then they're few and far between. I mean, you can do the math. I'll actually show the equation for this in a minute. If they last a long time, then it's much more likely that they're going to be less rare and easier to find. So whenever you start wondering about other civilizations existing in the cosmos, you start wondering about the longevity of civilizations. And one of the values of the Anthropocene, I think, as a concept, is that it situates us in sort of big time, in deep time, in geological time. And it's not only a way of thinking about our past, it's a way of thinking about our future. And we can ask, what is the Anthropocene? What will it be in Earth history? Will it be an event, an epoch, or some kind of a planetary transition? And in the geological timescale, there are examples of all these. When I say an event, I mean something like the Cretaceous-Tertiary boundary, the little centimeter of clay that marks the fallout from that asteroid that killed the dinosaurs 65 million years ago. That was an event. The actual change was very brief. The aftermath was long and interesting, and we're still in it. But in terms of the geological history, it was a thin layer. So the Anthropocene could be like that. It could just be a strange layer of, water, plastic bottles, and laptops, and our other debris. And if all we do is burn our fossil fuels in some sort of orgy of consumption and don't really think about the future, that may end up being what the Anthropocene is. But it could also be something longer lived. It's actually been proposed in the geologic timescale as an epoch. People talk about the Anthropocene epoch. Well, if it's really going to be an epoch, in geological time, that's often something that lasts for, say, 10 million years or that kind of timescale, like the Paleocene. was from 65 to 58 million years ago, the Paleocene epoch. So the third possibility, I think, is that it could actually be something more profound, a planetary transition. A few times in the history of Earth, the planet has gone through a major transition such that the rules of change on the planet are fundamentally altered before and after. An example I talked about earlier was the origin of life, which forever changed the planet. Another example, well, I mentioned the rise of oxygen. I think that rates as a planetary transition. There's also the Cambrian explosion about 600 million years ago when multicellular, complex animal and plant life burst on the scene and really forever changed the planet. So I wonder if the Anthropocene might also be a planetary transition, if somehow this new kind of geologic change that we've been discussing might be a part of the planet's operating system for the rest of time on this planet. But what would that take? Well, this is another way of asking, again, is human-style intelligence adaptive or self-limiting? Whatever's going on here, is it something that actually could last? Or is it something that is inherently self-destructive, self-limiting? The answer, of course, is we have a choice. As that great philosopher, Sarah Connor, in the movie Terminator, carved into the picnic table in that one scene down in Mexico, the future is unwritten. There is no fate but what we make. Okay, so obviously we don't know, but it may be that our actions will determine which of these the Anthropocene will be. It's funny because people talk about the Anthropocene and they look over on this right side, and the big debate now in the geologic history is if we've actually passed from the Holocene epoch to the Anthropocene epoch. But I actually think maybe they're looking at the wrong side of this chart. It may be, if you look over on the left side at the eons, the really big transitions, the origin of life, the Cambrian explosion, are representative of new eons. And I wonder if, in fact, maybe what we are talking about is at least potentially, if it's really going to be a transition in the way the planet operates, it might be something much more profound than a new epoch. It might be a new eon of geologic time that we're entering. Anyways, the problem, of course, is ourselves. And many sagacious, smart people have talked about a kind of 21st century bottleneck that we're facing. I'm talking about people like Sir Martin Rees, who wrote this book, Our Final Hour. He gives us a 50-50 chance of surviving the 21st century. Which doesn't sound great, but it's fighting odds. And E.O. Wilson, Harvard biologist, in The Future of Life, he also talked about this 21st century bottleneck. That is, if you look at this confluence of all these problems we're facing in areas of population, energy, global warming, biodiversity, and then these other potential high-tech problems of potentially dangerous new technologies, nano, bio, cyber, and experiments we might do that might run away from us, there's this sense of a bottleneck, a convergence, that either we will, at the end of some period of time, it's maybe a century, maybe 500 years, I don't know, but it's less than 1,000 years, that we will either come to a new maturity in the way that we deal globally with our technology and manage our world-changing technology. I mean, this is what we're dealing with. We now have technology that can change the world, so can we handle that? And the reason why people represent it as a bottleneck is because of this. In a sense, it's a choice, that we have all these ways to limit our future, but we also have ways to greatly enhance our future. Obviously, technology, this is a focus on the negatives, but those of us that enjoy our lifespan and the medical technology we live with and like to think that we would stop a dangerous asteroid in its tracks, recognize that there's a dual-sided nature to this. And so if you think of it as a bottleneck, that we could get to the other side and have a more mature relationship with our technology, or that a civilization could, then that introduces another possibility, the possibility of great longevity, where, in fact, natural disasters that otherwise would kill us are things that we've learned how to handle. And then that leads to this idea, this bottleneck idea leads to a sort of bifurcation in the lifetime of civilizations. What do I mean by that? Oh, and if this wasn't enough, we also have to worry about the zombie apocalypse. So there's really a lot to worry about. So, you know, if we don't make it through this bottleneck, you've heard about the habitable zone, right? The Goldilocks problem. Well, so if we don't make it through this bottleneck, one way of thinking about it is, you know, Mars was too hot, Mars was too cold, Venus was too hot, and Earth was too dumb. This is my friend John Lomberg drew this cartoon, but there's another possibility, of course, and one that I think we have no choice but to strive for. And that is the possibility of what I call quasi-immortality. That if there is this bifurcation in the lifetime of civilizations, what does a civilization look like that has made it through the other side of that bottleneck, that has really learned to use technology in the service of survival? And in my view, there's a possible state that even if it's rare, maybe most civilizations in our state are short-lived, and maybe technological prowess is usually not adaptive. But if some civilizations, if any civilizations, make it through the transition to being a sustainable technological global civilization, I think they may become sort of quasi-immortal. And what I mean by that is a sort of deep enough understanding of nature and self-understanding, and that may be the hard part, which gives an ability to forestall natural disasters and even eventually maybe spread beyond one planet, which gives a certain kind of life insurance policy. And I say quasi-immortality because the universe is probably not going to last forever, and I'm not sure even these really successful civilizations will be able to deal with that. Well, Isaac Asimov had a good science fiction story about that. But, and so I see I'm getting a little late on time, so I'm not going to go through all this really, but the point of this, and it's getting a little nerdy, but if you do the math, and you think about the number of civilizations here, and you think about the lifetime of civilizations, the way people normally think about this is there's some average lifetime, which people call L. But if you really take seriously this possibility of the transition to a really long lifetime, then the distribution doesn't look like this. It's not what we call a Gaussian with some average. There would be a Gaussian, some distribution of the short-lived civilizations, maybe like ours, the ones that don't make it through the bottleneck. But then there's some other tail, some super long-lived, almost infinite tail of really long life. And the interesting thing about that, if you do the math, this Drake equation, which you've probably heard of, which calculates the number of communicating civilizations based on all these different factors about stars and planets and the lifetime of civilizations, it sort of assumes a steady state. That is, it assumes there is an average lifetime of the civilization, and therefore the number, you can calculate the number, but it's not changing. But if you posit this idea of a super long lifetime state that's possible, then it's not a steady state, and in fact, you calculate that the number of civilizations in the universe is slowly increasing over time. And if they're helping each other out, it might even be increasing in a nonlinear way. And then you can get to some really bizarre possibilities, which I won't go into now. But the bottom line is that, well, one weird consequence of this is that it might be true that the average civilization, the typical civilization, is short-lived, and yet the universe is dominated by these super long-lived ones, because these quasi-immortals, they're sort of like vampires in that you can create them, but you can't destroy them. And so they slowly accumulate. And so what that means, possibly, is that the human process, we're used to thinking of L as our own future lifetime. The people that really came up with this math, people like Carl Sagan and Frank Drake and others, they used to talk about nuclear war, and if we blow ourselves up in a nuclear war, that means L might be really short, like 50 years or 100 years, and therefore there aren't any civilizations out there. There was this inherent coupling of L with our own prospect. But this picture actually means that the human prospect is not necessarily closely linked to the likely abundance of long-lived civilizations. That is, it may well be that we are doomed, but that there's a glorious future out there for intelligent life, but just we may not get to join the party. Or as, and my slide might be cut off on the bottom here, but as Franz Kafka put it, oh, there it is, yeah. There is hope. There's an infinite amount of hope in the universe, but not for us. That's one possibility. So Let me close by talking about some of the debates, what we call what I call the Anthropocene debates. This concept of the Anthropocene has stimulated a lot of interesting and some less interesting discussions. The least interesting is how do you pronounce it. Some people say Anthropocene, Anthropocene if you're British, or Anthropocene. I don't really care. Should it be an official geologic era? That, to me, has become a little bit less interesting. Too many articles, magazine articles, have focused on this debate. I think it almost doesn't matter now whether that official commission on stratigraphy adopts this or not, because it's become something that not only geologists, but historians and archaeologists and ethicists and philosophers are discussing. And it's a worthwhile discussion to think of ourselves in geologic time and think of ourselves as a geologic force, whether or not it becomes official. Now, when did it start? That's an interesting one. I'll come back to that in a minute. And do we need to fundamentally rethink the nature of nature? To me, this is perhaps the most interesting part of this. When you start realizing that we live on a planet that we ourselves have been profoundly altering, you start realizing that in some ways the comfortable dichotomies that we're used to thinking of don't completely work anymore. And for instance, the divide between what is natural and what is artifact. Well, for one thing, we're products of evolution, right? So we're natural, so therefore the things we do are natural in a certain sense, but also in a world where there is nothing, like it or not, really untouched by human civilization anymore. What does it really mean completely when we use the word natural? And also, this is filtered into some really interesting debates in the conservation and environmental community. Have we been sort of too nostalgic in our views of conservation, where a lot of the talk is of trying to restore some pristine pre-human time, but when you really look for that and look for that moment in history, it's hard to even find what it is we're seeking. And maybe it would be more fruitful to look at the world as it actually is now, and instead of thinking about the past, think about the future. What is it we want to enhance? What is it we want to preserve? And so there's this talk of sort of eco-pragmatism, and some of these debates have really sort of shaken up the environmental community. A lot of people respond negatively to the notion of the Anthropocene. It's easy to understand. In some ways, it's a very offensive notion. If you're not offended, in a certain sense, you're not paying attention. Is it just a narcissistic idea? Who are we to name a geological period after ourselves? It sort of carries an obnoxious implication. Do we think we're sort of gods now? Do we think we deserve to be in charge? I mean, in reality, in my view, it's not about whether we deserve this or whether we want to play this role. It's more waking up and recognizing that we're in this position and we better assume that responsibility. But you can understand why this is a bothersome notion. It sort of smacks uncomfortably of a biblical world created just for us. And in a certain sense, it's going backwards in that science has led us in exactly the opposite direction of this notion of ourselves as being central. You can think of what Carl Sagan called the great demotions. Right? If you think of the major accomplishments of the scientific revolution, Galileo showing us that the Earth wasn't the center of the universe, Darwin showing us that humans were not some special, distinct species, but were related to the history of all life. And we've learned that even more profoundly with modern molecular biology and with the wonders produced by the Hubble Space Telescope operated from right here in Baltimore. We've learned that this universe we live in is incredibly vast and incredibly old, and we were not even here for most of the story. For almost all of the story, we weren't here, so there's no way this story could be about us. We've learned all of this, and Carl Sagan said famously, "It is far better to grasp the universe the way it really is than to persist in delusions, however satisfying and reassuring." So that's what he meant by the great demotions. And now what? We're giving ourselves a great promotion? We're saying we're the center of it all? Is that what we're doing? I mean, does this place us back in the center of the story? And the answer is yes, it kind of does. And yes, that is very disturbing. But the point of science, as Carl did like to remind us, is not to comfort ourselves with what feels good, but to try to see things as they really are. and then deal honestly with what we've learned. And you can turn this quote around. If we want to grasp the universe the way it really is, we have to look at what's really going on Earth. And whether we like it or not, we are a big part of the story right now. If we add up the evidence, Earth science has to recognize the Anthropocene because the rules have changed and the Earth is becoming unrecognizable. So a lot of people, again, have had a strong response against this. In fact, here's something that was published recently by an environmental philosopher whose name is Kathleen Dean Moore. She called this Anthropocene is the wrong word. And she talks here about how, yes, we're bringing the Holocene to a dismal end, and you can read this yourself. She's talking about, how we've doomed ourselves and destroyed the prospects of all other beings, and basically an eloquent summary here of this moral monstrosity that we are. It's pretty anti-human, and you can sort of understand why. And she suggests, no, we should call this the unforgivable crime scene, or even just the obscene epoch. Now, she's got a point, but I worry about this anti-humanism as a major theme in the way we talk about the environment, about what's happening on Earth. If you look at the metaphors we typically use to describe the human imprint on Earth, we talk about we're a cancer on the Earth, we're a virus, we're criminals, we're raping and murdering the rainforest. And you can understand the origin of these. There's a truth to this. If you look at the patterns of our development, there is a lot that's sort of cancer-like. And yeah, when I hear about the imminent extinction of some great species of African rhinos, or the way that the elephants are threatened, or the big cats are threatened, and those are just the charismatic species, so many others in this mass extinction we're causing, it is a kind of crime. But I just think that these metaphors for ourselves are maybe not the most helpful as we go into the future. Can we think of ourselves, can we recognize the position that we're in, and yet think of some other ways to envision ourselves that help us carry into the future a more positive view of the imprint that we should be having, that we could have on the Earth? And I don't know exactly, but I've toyed with, and I'm not the first to suggest some of these. In a certain sense, we're like babies. Here we are. Nobody's ever taught us how to run a biosphere. We don't know what we're doing, but we find ourselves here, and we better learn to get good at it. Or it's almost like somebody who wakes up at the wheel driving a heavy truck down a road and is going, whoa, I don't know how to drive, but here I am. What do I do? That's almost the situation we are on this planet. Like it or not, we have to learn how to drive this thing. I have a couple other metaphors, but I'm running low on time. So maybe some of you know the notion of a generation ship, because of probably a 2 or 3 of you, I see a couple nodding heads, are science fiction geeks. And in some sense, I think we're on a generation ship, and that we're kind of waking up to our new reality and realizing we have to find the controls of this thing and learn how to drive it. Or you could say maybe we're like the microbiome of the Earth, and we want to try to be the commensal microbiome, the good microbes that actually live well with their host. Or in some sense, we're like the nervous system. Maybe we want to be the brain of the Earth. These are all just sort of different ways to think of ourselves that maybe can be a little more aspirational. I'm going to skip a couple things here. Somebody recently said maybe we shouldn't think about the footprint, but the handprint. After all, this is what really makes us human. Interesting idea. Okay, so getting back to very briefly to this question of when it started, people have talked about, well, maybe it goes back 5 or even 10,000 years to when we really started, or at least 5,000 years to when we started altering the landscape with agriculture. And in fact, at that time, not only started changing the land surface of the planet, but changing the carbon cycle. And actually, there's evidence that climate change by humans that started thousands of years ago. Some people think it should have started around the beginning of the Industrial Revolution, when steam engines started up and we really started using fossil fuels and changing the atmosphere. There's been this idea that we should mark it from the date of the first atomic bomb test. After all, that leaves a nifty isotopic signature for future generations to find, and it certainly has a metaphorical potency of our realizing our powers. Now, these are all interesting moments in the development of humanity as a global species. And unfortunately, this has sort of devolved into an argument. People are actually fighting over, this is, when the Anthropocene should start. No, this isn't, because they want to make it official. And I think that's a little bit silly. It's a little bit like arguing over, whether Pluto's a planet or not. Because what's interesting is the qualities of Pluto-like objects, not what we call it, right? And similarly, it's interesting to note these different stages in human presence on Earth. And I don't really care what they, how that argument comes out about what officially gets proclaimed as the beginning of the Anthropocene. But as I think about this, I've also thought of a new way, perhaps, to think of the beginning that is maybe even a little bit more hopeful. And that is that in a certain sense, maybe it's just getting started. Maybe it begins with the end of our innocence, with a mass awareness of our role as world changers. Because really what makes this time, the Anthropocene, unprecedented here on the planet and worthy of a new name is our growing knowledge of what we're doing on this planet. Self-aware, self-conscious global change, I think, is a completely new phenomenon and a remarkable one on this planet. And so I'm wondering if we can define a new phase, the mature Anthropocene, marked by that fourth kind of planetary change, intentional, and regard that as something that we are trying to bring on. In that sense, we can think of the Anthropocene as something that we should strive for rather than that we should run away from. And in that sense, also, it's just getting started in our conversations. And what we're doing tonight, we're hopefully, in some tiny way, helping to bring on the mature Anthropocene. So this is where I get the title of my talk and the title of the book I'm writing now, Terra, Sapiens. It's the notion, the vision of a wise Earth. That's what these words literally mean. And in order to get there, we have to become a new kind of entity on this planet. We need to learn to live comfortably over the long haul with our world-changing technology. Now, one key to this, I think, is the widespread propagation of a worldview that is global and multi-generational. And one hopeful truth is that I see this worldview developing. I mean, it's very easy to get discouraged, but the fact is, with these little gizmos that we can pull out of our pockets and have an instant conversation with somebody in Egypt about what's happening and pull up any data set from any satellite orbiting the Earth, we are becoming a new kind of entity, a globally connected, communicating, data exchanging entity. And that change is not necessarily completely apparent when you read the newspaper every day, and yet it is happening. Is it happening enough? Is it happening fast enough? I don't know, but I think there is a profound change occurring in the way we relate globally to one another and to our future. And one interesting question as a scientist especially, I think, what is the role of science in this? And there's been a lot of discussion lately in the community about how should scientists be activists, when we're worried about climate and so forth. And it's an interesting question because there's dangers there. I mean, when you see an emergency, you want to do something about it. You don't just want to model it, right? But at the same time, we strive to be a sort of objective voice. And so what is the proper role? It's not completely clear. It's an interesting question. But one thing that I find hopeful is that I think just by doing science and communicating science, science itself does lead to certain values that may actually be the very ones that humanity needs to survive this transition. Because when we look at Earth from space, say, with satellites, it doesn't look like this. It looks like this. And what we see, what science reveals, is this global system of connected cycles and the reality of the world revealed by science is long-term and global. That's what we notice when we study the Earth. So science by itself, I think, just by doing what we do and communicating what we do, it promotes a worldview that is global and multi-generational. Just the worldview, I think, that we need. So it's true, science is deeply implicated in the Anthropocene. We have a responsibility. Through technology, which has a tight relationship with science and technology are not the same thing, but they're like that. We have helped to bring on this great acceleration. We wouldn't be in this mess without science, but I think we won't survive without a lot more of it and without the worldview that it naturally encourages. Now, I'm finishing up here, but one of the joys of working in the Library of Congress over the last year has been, well, there's a lot of books there. And I've gotten to read a lot of them. And one of my sort of pet side projects has been something that I think I'll incorporate as sort of a chapter or a section of this book I'm writing, and I call it A Brief History of the Future, where I've been reading a lot of books about the future written in the past. Because it's very interesting to see what people say 100 years ago said about now, and what kinds of things they predicted, and how people get the future right and how they get it wrong, and use that to try to illuminate how we're thinking about the future now. And it's very interesting. A lot of smart people said a lot of very prescient things about where we would be now, say 100 years ago. But they also missed a lot. And of course what they miss are the game changers. And nobody really gets it right. And out of this exercise, I've become convinced that nobody's right about the world 100 years from now. The climate modelers aren't right. The politicians aren't right. The prophets of doom aren't right. The techno-utopians aren't right. We don't know, and I bet you, looking back 100 years, that's the one prediction I feel like I can safely say. We don't know. And that uncertainty, though, I think gives us a little room for hope. You know, we can't say that we're certainly doomed because the future is just so uncertain. But this book, in particular, is one of my favorites that I've read in this sort of brief history of the future. It's by J.D. Bernal, and it's called The World, the Flesh, and the Devil. And I don't have the date here, but I think it was written around 1926 or 28. And no less a sage than Arthur C. Clarke called this book the most brilliant attempt at scientific prediction ever made. So that's a pretty strong endorsement by Sir Arthur. And I recommend the book. It's really good. But just in case you don't get to read it, I'm going to give you a little spoiler here. Here's the very end of the book. This is the last paragraph. J.D. said, "We hold the future still timidly, but perceive it for the first time as a function of our own action. Having seen it, are we to turn away from something that offends the very nature of our earliest desires? Or is the recognition of our new powers sufficient to change those desires into the service of the future, which they will have to bring about?" So in conclusion, technological innovation is changing our world in surprising, accelerating, and unpredictable ways. And possibilities that until recently seemed magical are now imminent. So the future is frightening and exhilarating, but above all, it really is unpredictable. And this uncertainty leaves us room for hope and for choice and faith in ourselves. Personally, my view is that we're just getting started on this planet. And a quote from the Shakespeare Library, which I walk past every day on my way to work now, is, "We know what we are, but know not what we may be." Okay, thank you very much.